folks, welcome to example 4. So here we have a sum that we want to evaluate. We can see the capital sigma there, I should say. Well, it is capital S in the Greek alphabet, but that's a sigma. And I see I've got an infinity up here. Right, so I've got an infinite series, and it's a geometric series. We can see that there's a multiplier of 1/4 because 1/4 keeps on getting raised to different powers. So if I take a look here, and let me just go ahead and draw my line this way because I think I'll run out of room on the top. This is an infinite geometric series. And it can be one of those mind trips to think you could add numbers infinitely and they might not blow up to infinity themselves. Like I could keep adding and adding and adding and adding numbers together and they won't blow up to infinity. And the way we determine that is we look at the R value, the ratio value. And in this particular case, we can see that 1/4 is the one is the expression that's in, or I should say the fraction that's the multiplier. So our ratio here is 1/4. And the rule we have is if the absolute value of R is less than 1, then our series will converge. And when I say my series will converge, it means that this giant infinite sum will ultimately be a number. Because sometimes you might think if you added numbers forever, they would add to infinity, but these don't. All right, it's either gonna add to 50/3, 200, or 200/3. This is not a divergent series. All right, if R in absolute value is greater than 1, then we would have D as our answer. So for example, if this had been the number 5/4, then D would be our answer. Right, 3/4, it would converge. 2/4, it would converge. 1/4, it converges. Anything larger than 1, it diverges. All right, meaning it would blow up to infinity. So another way, again, if it's divergent, then that sum, I'll just put a sub whatever, would be infinity. That's what it means to diverge. To converge means it goes to a number. All right, let me erase all this. Let's go get our formula. So whenever you have an infinite geometric series, we know that the sum is always a sub 1 in ratio to 1 minus R. And we know our R value. I'm about to put 1/4 here. All right, and if I want a sub 1, all that means is find the first term in this series. So if I'm starting at 1, let's go crunch some numbers. A sub 1 in this case would be 50 times 1/4 to the first power. Okay, well that's 50 times 1/4, which is 50/4. Great. So let's go sub this in. So my numerator is 50/4. My denominator is 1 minus 1/4. And then you can use your calculator if you want, but I'm actually just going to do this by hand. So this is 50/4. All right, 1 minus 1/4 is 3/4. When you divide by a fraction, that's like multiplying by a reciprocal. So I'm going to take 50/4 and multiply it by 4/3. The 4's cancel, and ultimately I'm left with my sum of 50/3. All right, thanks so much, everyone. Bye.